Semua sihat? Alhamdulillah. Dah makan tengah hari? Belum kan? Pukul 12. Okay. So let's get started. All right, can you all see the slides? Okay, good. All right, we're gonna move on to the next topic, which is clean room. So we're gonna look at the space required to do the fabrication processes. So we're gonna look at what is a clean room, what does it take to be a clean room, what are the important parameters that need to be controlled, monitored, and acted upon if you need to in a typical semiconductor clean room. Right, so after finishing this clean room topic, we're gonna go into our first process, which is oxidation tomorrow. So before we move on, as usual, let us recap what have we learned in the previous topic, which was on wafer characterization. So let's discuss a few things before we move on. All right. Why do we need to characterize incoming wafers? Okay, let's move on to the second one. The first one is quite general. So why do we need to do characterization on incoming wafers? Okay, someone would like to share on this? To reduce defects, okay. Can we reduce defects with the characterization? Okay, tak boleh nak reduce, we can only know what is the incoming level of the defects the suppliers, okay. Okay, ada lagi, why do we need to do characterization of the incoming wafers? To control the quality, yes, to control the quality. So even though we have already agreed with the supplier that they have to supply to a certain level of requirements for our wafers, so there will still be occasions where certain parameters are met, or we have issues occasionally with certain issues, certain aspects, if you like, in the wafer control. All right, so what characterizations can be used to study the surface of a silicon wafer? So what sort of characterizations can we do to control the surface, or to investigate the surface? AFM, okay, Hazika, good, AFM. Right, Hazika, what do we know from AFM? What do we want to know from AFM? Can I mute yourself, Hazika? And talk, lama dah saya tak dengar suara student ni. Okay.
Can know the surface roughness.
All right, good. Surface roughness in the form of what's the exact parameter do we see for the surface roughness?
SQM.
RMS,
I forgot
RMS.
RMS, huh?
Yes,
Okay.
RMS, surface roughness. So RMS is root mean square. All right, thank you. All right, what else can we use? Others? You cakap pula ni ya? Lama dah saya tak dengar suara student ni. Saya cakap dengan dia sekarang bosan sikit. So it's different. This is the the most obvious drawback of running an online class. So let's cheer up. Let's cheer up the session. Okay, next. What characterization can we use to study the surface? What else can we do other than AFM? Let me call you for you to unmute. Zuriati. Zuriati, turn yourself on. Your mic on. Zuriati, can you hear me? Tak ada ke? Faika. Okay, Faika, unmute yourself.
Yes, doctor.
Okay, what else can we do? What else can we use to study the surface?
Optical microscope.
All right, optical microscope. What do we see from optical microscope?
The
What
imaging.
can we see in general?
Maybe the imaging. I don't know.
All right, the image of the surface, right?
Yeah. Yes.
All right, okay, thank you. So if we have structures, then we should be able to see structures. If you have defects, then we should be able to see defects, right? If it's only a bare wafer, then you hardly see anything from optical microscope. Okay, one more. Apa lagi kita boleh guna to study the surface? Anjahira?
Doctor.
Alright. Apa lagi kita boleh guna to study the surface?
SEM.
Alright, good. SEM. So what do you see from SEM?
The surface of the silicon.
Okay, so if let's say if you want to compare what can you see from optical microscope versus what do you want to see, what you can see on SEM. So what is the extra you can see on SEM yang tak nampak dekat mikroskop?
I don't know.
Apa limitation microscope yang you can overcome on SEM? Or maybe you can see on SEM, you can't see on optical microscope, in other words.
I'm not sure.
All right, that's fine. It's okay. Okay, anyone would like to add on that? And what can you see on SEM that maybe you can't see on microscope? Well, it can be anything, but then mesti ada dia punya features that you can see on SEM, right? But you can't on optical microscope. Anyone would like to? Yishin, what do we see on SEM but we don't see on optical microscope? Yishin? Tak ada ke Yishin? Not there. Ilham. Ilham, anything? What do we see on SEM? Why do you want to go for SEM? Why don't you just go on microscope? All right, not sure. Okay. Fazira.
Yeah.
Right, Fazira. What do you see on SEM that you don't on microscope?
I think the scale on SEM is more.
The scale
It's more, and SEM is more detailed.
yes. The scale is detailed, so basically you can see something smaller or something bigger than microscope.
Something smaller.
Small, right? Good, right. So kalau the things that you would like to see, the features or defects or whatever lah structure yang ada kat atas wafer tu, if it's small enough, then you might not be able to see on microscope, but you can only see on SEM. Why is it so? Kenapa? Why is it the case? Kenapa you tak nampak on microscope tapi you nampak on SEM?
I don't know.
You don't know? Okay, who knows? Go Chingwei. If you go to features small enough, why can you see on SEM but you can't see on scope? Top view ke cross section? Okay, let's talk about top view. Kalau microscope ni cross section lagi susah lah. Cross section ni usually is more targeted for smaller features. Right, Chingwei, why do we see on SEM but we don't on microscope? Lens, all right, yeah, maybe lens, okay. But what's the gist of the system? Apa yang menyebabkan sistem dua-dua tu berbeza? To begin with, yang paling basic lah. Why is it? No, why do you see on SEM tapi tak kat scope tak nampak? As a physics student, kenapa you tak nampak on scope? Tapi kita nampak on SEM. Okay, other than Chiwe, siapa lagi? Ain Natasha. Kan kita discuss sikit. It's too boring in my office. And it's very cloudy outside and it's boring here. So low reflection. You mean low reflection from SEM? Ian? SEM 3D image. Yes, 3D, yes, but what makes you see the 3D? There, Fazira got it. SEM uses electron beam, okay? But microscope uses. So habiskan ayat tu, Fazira. SEM pakai electron beam, microscope pakai apa? Lens lah, tapi okay. Sekarang you have to compare apple with apple. Yes, got it. What light? Visible light, right? Lampu biasa kan? So what's the difference between the visible light and electron beam? Apa beza? What's the fundamental difference that makes you see on SEM but not on scope?
The wavelength?
Yes. Which one is smaller?
My electron.
Electron beam is smaller, right?
Yeah.
So itulah fundamental difference here, okay? So bila you nak tengok smaller features, you have to use smaller wavelength as your beam or light source. Now you can see smaller things. So that's why we go for microscope for smaller features, defects, or I don't know, particles, or the gate, oxide, or whatever. We call it features generally, okay? So you cannot miss that because it's the fundamental of scope and SEM. Okay, done. Let's move on. So working principle, you just go through and what you call think for yourself, right? It's the working principle. So let's move on to today's topic. So clean room. Kita discuss here. Let's just instead of put things in your words in the chat box, you can just reply, unmute yourself. So make our class more lively. So clean room. What is a clean room? Kalau perkataan tu kepada dua, it's a clean plus room, right? Clean room. What is clean room? Generally, what is a clean room? What do you know as a clean room? Nabila. before we study the topic, so what crosses your mind when we talk about clean room? Nabila? No dust, okay, all right. No dust in a clean room. What else? Why do they dress like that? Kenapa dia pakai bunny suit? We call it bunny suit in the fab, okay? Bunny suit. Cuma dia tak ada telinga. So why do they dress like that? What are we trying to protect here? Apa lagi? Keywords around clean room to reduce contamination. Good. Okay, what else? Apa lagi keywords around clean room before we go to the content? Semalam or 2 days I bagi kat you videos kan yang micron tu. Well, you can see those are the spaces in clean room. So that's how it looks like, right? So some are, you have to dress like this. Some fabs, they have color code for different employees, and some just have one for employees and one for suppliers or vendors and one for some other purposes, perhaps visitors. So but generally they dress up like that. Ada face mask, ada what I call goggles there, ada what I call the hat. Some hats are connected to the whole gowning, and some are separate where you have to put it first and then button up and then only come to the long gowns. Okay, then you have the boots, right? We'll see later on, and you have gloves eventually. So some purpose need single layer, some other purposes need double layers. So generally that's how you have to gown up if you work in a clean room, right? Right. So what is a clean room? A clean room is a clean environment that is designed to reduce contamination of processes and materials, right? So you should be wearing that throughout your time in the fab. So as long as you masuk fab, so generally office building will be separated from with a fab. So the moment you want to go into the fab, then you have to go to the gowning room like that and dress up. Okay. So this is accomplished by removing or reducing contamination sources. So partly by gowning as well. Okay. So clean room is typically used in manufacturing or scientific research. It's a controlled environment that has low level of pollutants. So the keyword here is low level of pollutants or contamination, if you like. Dust, airborne, aerosol particles, chemical vapors, and some other contamination as well. So the control level of contamination specified by number of particles per meter cube. So we'll see later on what sort of classification that we use to categorize spaces in clean room. So some space will be called class 1, class 10, class 100, class 1000, so on and so forth. You'll see the standards on how the classes are divided in the first place. So ambient air outside, just to give you some perspective, ambient air outside in a typical city environment, if you go out to, I don't know, Queens Bay or Georgetown, so we typically have somewhere around 35 million particles per meter cube. So maksudnya dalam 1 meter height by 1 meter width by 1 meter long punya area, or 1 meter cube punya area, will typically find 35 million particles per meter cube. 0.5 mm or larger in diameter. So of this particular size, corresponding to ISO 9 clean room, which is at the lowest level of clean room standard. So we'll see later on what does it mean. So let me just play one video for you, even though there's no audio. Let me just go through the content from the YouTube. Give me 1 minute. The video is on the link, by the way. Where is the video? Hold on. Alrighty, okay. WhatsApp. This one is by one supplier of a clean room. Right, can you see the YouTube page now? Can you see? All right, good. So it's a 4-minute video. I'll just go for maybe 3 minutes. So you think of the content, huh? I'll just narrate along the way. But you can watch again in your from the link given. So what is a clean room? Several parameters of control, such as contamination, pressure, temperature, and humidity are controlled as well. Even personal access is controlled. If you work in a fab, usually you need to go for a certification or testing for a test before you are given access to enter the fab. So contaminants, organic, non-organic particles, static charges are contaminants as well. What creates contamination? So we create contamination. So that's why we have to gun up. Hair, spit, sweating, clothing debris, dia punya apa jahitan tu, duct tape, pencil, cardboard. So you need a special book, right? Clean room book in order for you to go into a fab and work. Contamination is measured by amount of particles per cubic foot of air or meter cube. Particles are measured in micron. So how big is a micron? So our hair is like 50 to 70 micron. Pollen is smaller, 30 to 50. So this is the classification, if you like, of ISO. So class 1 is the cleanest one, lowest one is the cleanest one there. One half size micron particle per cubic foot. So lagi tinggi lagi tak clean in the table. So there's a standard governing all the clean room protocols and procedures. Right. So this is all the ISO category of the particle size, range, and numbers. So we'll see later on in our notes from ISO 1 to 9. So yeah, it's typical in wafer fab, which requires tight control of the amount of size of particles. On top, we also control temperature, humidity, conductivity, static charge, interference, cleanliness of the equipment, and many more. Right? It's an enclosure, by the way. Macam you work in a box, in a control box. So we want to control product yield, protect sensitive equipment, control process, impress clients, of course. If you run a clean room, if you run a fab, you want to have customers. So this is just Porta Fab as a company which offers clean room. Doesn't necessarily have to be a fixed space. It can also be a modular where you can move around. Cumanya kalau modular tu it's more applicable to lab lah, lab yang ada clean room as a space. Tapi kalau wafer fab is typically a proper building punya ni lah environment. Okay, so let's go back to the. Okay, can you now see the slides? Let me close the YouTube. Okay, sekarang nampak slide tak? Let me show the slides again, right? Can you see the slide now? Did I not share the slide? Okay, sekejap. connected. Hold on. Okay, can you hold on? Is it broken? Okay, can you see the slides now? I think my line is having problem just now. Okay, can you see? Okay, good. I did a disconnection, I think. Okay, so let's move on to the content. Okay, clean room. Okay, right. So we have watched the introduction to clean room, more or less. Okay, so let's move on. So why do we need a clean room? It's a dirty world out here, so you can't do fabrication out here in your ambient or in your typical condition, in typical atmosphere. So uncountable particles in air, so many particles, so tens of millions of particles in a typical outside environment of all sizes, shapes, and properties. So it won't work for the fabrication. So now we're talking about fabricating small devices, particularly if you talk about transistors. So we're talking about fabrication of small feature size devices. So therefore, if you have particles this big, just like on this slide, if you look at this 4 or 5 by 4 by 5, 4.5 micron by 4.5 micron squared. So this single particle can kill your device instantly, right? So clean room as an environment, so it's used in semiconductor manufacturing, biotech, life sciences, and some other relevant environment as well, which are sensitive to environmental contamination. So you want to control contaminations from the space, it has to be a clean room. So stuff entering or leaving the space through airlocks. Any of you pernah masuk clean room ke? Anyone pernah masuk clean room sebelum ni? Tak masuk Do we have a clean room in School of Physics? Tak pernah. So do we have a clean room in School of Physics? What do you think? Do we have clean room at all? No idea? We don't, right? We don't. We used to have one in solid state physics lab, but long time ago, right? Long time ago. So now it's not working, so we don't have clean room at the moment. So if you want to enter a clean room, it has to be through an air shower. Air shower ni is, you can see from the right hand side of the image. So that stuff is in the space. So dia ada dua pintu. You masuk pintu pertama. And you enter the first door. So assuming and I think it's a lady, right? Assuming she entered from the other doors that you can see open now. So bila you buka pintu pertama from that side, the pintu belah dalam tu kan. So the second door on this side will be automatically locked. So the doors cannot be open both at the same time. So that's how we control clean room. Okay, you buka pintu sana, pintu sini akan di lock. Then the moment the first door is locked, so air shower will be running in the space. So what you have to do is you have to pusing orang dan angkat tangan, clean up. So you have to basically mandi, but then mandi dengan air shower. That's why we call it air shower. So you have to pusing keliling macam dekat airport tu kan, nak scan left, right, up, down. So you have to remove potential contaminants or particles maybe from the from the gowning punya suit, from your bunny suit. Nak pakai bunny suit pun ada sequence. You cannot just wear your bunny suit the way you like. Dia ada sequence. Kalau you work in a fab or you go for an internship in a wafer fab, so the very first thing that you will train is on the clean room protocol, procedures, gowning up, and all the stuff. So this sequence, sebab dia ada hood, dia ada face mask, dia ada glove, dia ada boots and coveralls. Coveralls is the yang panjang sekali lah. So they have to be worn in sequence. So you have to follow the sequence in order to wear your bunny suit correctly. Okay. Lepas you go through all the training, all the basic training, safety, gowning, and a couple more, then only you'll be given a test. You have to pass the test, then you'll be given an access to the space. Right, baru boleh masuk. Selagi tak pass tu, selagi tak go through the training, then you are not allowed to enter the fab. Okay. So it's quite complicated. Okay? So because you have to have your access. So air from outside is filtered to exclude dust. When you want to enter the clean room, bila you habis the air shower tadi, the moment you finish the air shower, I think, if I'm not mistaken, it's about 20 seconds of shower, so you can sort of mandi 20 seconds. So the moment your air shower is finished, so your second door will be opened right in front of you. And then the moment you want to open the door, you will feel some pressure coming to your face because the pressure from inside the clean room is positive. So it's called positive pressure punya mechanism. So why do you think we have to have positive pressure in a clean room? Kenapa you buka pintu dia macam susah dan angin rush into your face? Any idea kenapa kena perlu ada positive pressure dalam fab? Ada jawapan ada kat second point So you want to keep a positive pressure in the fab because kalau ada particles from the fab, you want to push them outside instead of particle dari luar masuk. Kalau luar pressure tinggi, and particle from the outside will go into the fab, but we don't want that to happen, of course. So that's why the fab is set at positive pressure or pressure higher than the previous environment or the neighboring environment, because you want to push all the potential contaminants or particles outside of the clean room. Okay, air from outside is filtered to exclude dust, and air from inside is constantly recirculated. So kita filter the incoming air, and then there'll be HEPA filter dekat bumbung. You'll see later on. You can also see here from the right hand side of the image, there are HEPA filters or high efficiency particulate air filters or HEPA, or we also have ALPA filters, ultra low particulate air, where particles of certain sizes are filtered before the air is injected into the space and recirculated dekat dinding. Dia masuk kat dinding, turun bawah. Bila pressure tu turun, is actually coming in a laminar flow. Laminar means it's very uniform, and dia akan turun. Even you tak pernah masuk fab kan? If you see in a fab later on, or you can try on YouTube later on, you can see the floors in a clean room are usually perforated. Perforated maksudnya floor tu ada lubang supaya you can sustain the laminar flow. Air yang coming from the HEPA or ALPA are coming down and going to the perforated floors, masuk ikut lubang. Then it will be recirculated on the wall, through the wall, and then coming out again. So dia akan jadi circulation macam ni lah. So if the floors are not perforated, kalau kita pakai semen biasa, of course it's dusty. So the flow from the filters are coming like this, but then it's going to hit the floor and it's going to be reflected multiple ways. So it's going to cause turbulence. So turbulence is a big no-no in a wafer fab. We don't want to have turbulence because it could create particles, it could send particles from the floor on your wafers and then contaminate devices, so on and so forth. So you need to have perforated floors, okay, perforated. So the clean room is kept at a positive pressure. So if any leaks occur, air leaks out of the chamber, so air leaks to the neighboring environment rather than the air from the environment coming into the space. Then only you can retain the level of your clean room, right? HVAC or economy system, HVAC control humidity to low levels such that extra equipment ionizers is necessary to prevent electrostatic discharge problems. So you're going to have ESD, electrostatic discharge problem, that could also kill your device. So therefore you need to have ionizers on top of the system. So you can see the images there. The clean room is kept at positive pressure, and on the right hand side we have the system of filtration by the ALPA or HEPA, and then we have circulation, we have laminar flow in space. Right, so this is how turbulence and laminar looks like. So you can turbulence on the left because there is no laminar flow. Maksudnya air yang coming from the filters are reflected at the floor because there's no holes to begin with. So dia tak boleh masuk through the holes to be recirculated again. So you will see turbulence on the floor, and turbulence will actually push some of the unwanted particles or dust or whatnot back up that will potentially land on your wafers and devices. So on the other hand, if you have laminar flow like the one on the right, so you will see a more uniform flow throughout the space. And then they're going to be recirculated again, coming back through the filters, recirculated, coming back through the filters forever. Okay. So the filters have to be replaced every now and then. There'll be specifications for that. So if you talk about with a fab, usually you will talk about specifications. Specification is spec lah, macam SOP lah, standard operating procedures. So you will find perhaps on the HEPA or ALPA filters PM or preventive maintenance. You will probably find that the filters have to be replaced like semi-annually or annually or twice or biannually or in fact quarterly or monthly. So depending on the requirements of the products. Okay. So clean rooms are classified by how clean the air is, just like what we watched in the video just now. So it's categorized by ISO class. So you can see from ISO 1 to 9. So if you can see from ISO number 1, so you can see the number of particles is 10 for more than 0.1 micron. Okay, on the other hand, if you see ISO standard on the left, you can also map that to another standard on the right, or STD209E equivalent to. So for example, if you look at ISO 3, it is equal to class 1 environment. So that's how you call environment in a clean room. Class 1 is ISO 3, class 10 to ISO 4, and so on and so forth. If you go down the table from 1 to 9, or class 1 to 100,000, so the space is dirtier, it's getting dirtier, right? Because you can see, for example, if you look at particles in column 0.1 micron, if you are in clean room class 1, row number 3 tu, so particle punya count is 1,000 of more than 0.1 micron. But on the other hand, if you go to class 1,000 ISO 6, so it's about 1 million, right, of the same size. So that's how the space or the clean room is categorized, right? Walaupun they are, you'll probably see one with a fab. Actually dalam fab tu dia ada banyak space. So dan space ni dia punya kelas dia berbeza. Yang paling sensitive is class 1, then if it's less sensitive, they go to class 10, class 100, class 1000. Okay. So contamination source, there are many sources of contamination. Right? You tengok kat gambar on the right tu apa jadi? What you can see there, no makeup, right? No makeup. Kenapa tak boleh pakai makeup dalam clean room? Why do you think so? Why no makeup in clean room? Any idea? Aniza, why do you think there is no makeup allowed in clean room? Aniza? Shamim. Shamim, why no makeup? It's dusty, right? Okay, dusty. Really? Betul ke dusty makeup? Which one is dusty? Chemical substance, yes. Dusty, yes. Chemical, yes. Apa lagi yang ada kat makeup tu? When you wear your makeup, what is in the makeup? Pernah check tak? Dia punya, do you usually go like, beli makeup ada kat belakang ni? Do you check the contents? Or you just buy oil? Yes, oil. Betul. Lagi apa lagi? Ada? Chemical substance, oil, dust. Lagi apa lagi ada kat makeup? You duduk kat rumah aja, you boleh check pakailah go like what is in the makeup, why is it forbidden, right? Cuba tengok dekat contamination tu, contamination source, many of them are in the makeup, right? So kalau if you are into makeup and dressing up, then maybe wafer fab is not for you, right? To be frank, okay, or you can work in a wafer fab but without makeup. That's it. So particles are dust. It's coming from the skin, so from the hair. Tadi kita tengok video. So from the makeup as well, particles. Kalau you pakai foundation kan, maybe dia ada, there's a bit of dust as well. Kalau bedak, of course, dust. You can see that in the air, right? So chemicals, oil, grease, metal ions. In fact, metal ions as well. Perfume is a big no-no as well. So kalau you masuk fab, no one is gonna smell you, by the way, but it's not loud. Okay. So if you are into, if you want to wear perfume, then I think the bare minimum is okay. Just to be what you call, what's the best word? I don't have a word for that. Bagi decent lah, decent as a person, but there's no extras to make you smell good or what, to attract people. No, not loud. Biological, bacteria, fungi, rodents. Ultraviolet. So these are all sources of contamination in the fab. So no makeup. Bila you join internship ataupun you get a job in wafer fab, then they'll also say this, no makeup. Trust me. Right, particle characteristics. 50 micron particles are visible. Average human hair is about 100 microns. So if you talk about particles of 50 micron, then it will just be half of our hair width, more or less. So you can see sometimes kalau you tak nampak, kalau you agak rabun, maybe you cannot see, but usually you'll see. Humans generate more than 1 times 10 to the 5, hundreds of thousands particles per minute when we are in no motion. So kalau kita tak ada pergerakan, duduk senyap, so kita generate about 100,000 of particles per minute. You duduk senyap-senyap 2 minit, then you're generating double. So fully down, motionless, tak bergerak. Just imagine if you move, if you walk, or run, or you do stuff, then particles will be all around you. Generated by our body, right? Humans can generate more than 1 times 10 to the 6 or 1 million particles per minute when walking in the clean room. So you're gowning up pun at least, if you don't, then at least 1 million particles per minute when walking in the clean room. So just imagine if you have to walk from the entrance to your department, to your equipment, or to your process, that's probably 300, 400 meters away. Then just imagine how many particles have you generated along the way. Contamination sources, people generate 75 of the sources in the fab untuk contamination. So 75% of the contamination sources are from people. Tu gambar from sejarah yang bawah tu. So that's how we are gowned up in the fab. So kita pegang wafer, tengok tu, pegang wafer pakai apa tu? What do you think the guy is using to hold the wafer? Tengok dia pakai apa tu? Nak pegang wafer tu. Any idea? It's called vacuum wand or vacuum handler, right? Vacuum wand or vacuum handler. usually is handled by equipment guys, equipment tech or equipment engineers. So untuk tengok wafer, inspect wafer sama ada problem or not. Some cases you might be able to see the defects or the problem right away by your naked eyes. And in some other condition, you might not be able to. You have to go down to the scope, or if it's too small, then you have to go to the SEM. Ventilation gives you 15% of contamination. Room structure, 5%. Equipment, another 5%. Kenapa equipment bagi contamination? How? How does it give us contamination? What do you think? Macam mana equipment boleh bagi contamination? Any idea? Apa equipment bagi contamination? What is it doing? Anyone? Kita stop at this page. But last question. Why equipments give contamination? How? Jenny, how? How equipments generate contaminants? Can you unmute yourself? Dari heat produced? Yes. If you talk about heat contamination, yes. But it's not generally contamination. Okay, how? What is the other way of equipments generating contaminants? Kenapa? Macam mana dia generate contaminants? Any idea? Izan, any idea Izan? Macam mana equipment boleh generate contaminant? Bukan hidup senyap ke? Any idea? Come on, last question before we wrap up for today. No idea? Inas? How Inas? Macam mana contamination datang dari equipment? Can you unmute yourself?
I don't know, Doctor.
Inas? Okay. Tolong kuat sikit Inas, tak dengar. How?
Dari orang-orang yang bergerak kot.
Macam mana equipment boleh generate partikel ni? Equipment tu tak bergerak kan? Is it moving? Is the equipment moving?
Tak.
Tak kan, dia tak bergerak di tempat dia kan? Tapi dalam equipment tu gerak. Robot arm tu bergerak.
Bergerak kot.
Kena bergerak kan? Kalau tak bergerak macam mana wafer nak bergerak kan? Right, so some parts, we also have some moving parts in the equipment. Okay? So walaupun equipment tu dia tak adalah bergerak pergi tempat lain. Tapi some moving parts actually generate particles as well. Okay, electric, what do you mean? Anis? Unmute please. Electric, what do you mean? Equipment electric, contamination, how? Contaminant from electric. Okay, what does it generate? Electric tu dia generate apa yang jadi contaminant tu? Electric, no, not directly though. Mungkin ada heat lah, but then heat is not the typical contaminants that we are talking about. Generally, it's due to the moving part. Usually dekat atas equipment yang saya jaga dulu tu, it's called tail track untuk CD process dalam lithography. It's for CDs for code, expose and develop. We'll see later on in lithography process. Dekat atas tu ada fan FFU, fan flow unit. So dia ada fan yang moving to retain the temperature, to retain the flow rate and everything. So that one consists of moving parts as well. Fan kan bergerak. So we have moving parts in the equipment, around the equipment, maybe on top of equipment or by the side of equipment, or in fact below the equipment. So this stuff generate contaminant as well. So which could eventually contaminate the environment as well to some level because they are there forever doing the job. So therefore, they have to be monitored in terms of contamination sources. Right, so I think that's all for today. Okay, Syah, kenapa tak boleh pakai makeup sedangkan kita dah pakai PPE? Right, good question. So why do you think so? So you tengok gambar dekat apa tu? You tengok gambar dekat kiri tu. Do you cover your whole face or not? Kita cover whole face. Dan you know, bila you talk about wearing makeup, then it's on the face, right? Usually, walaupun you cover some part of the face, so there'll potentially be contamination as well outside. Ataupun dia keluar ke, because if it's too small, if you're talking about dust, so maybe it can even leak through the mask as well, or the space, ataupun you know, you sweat and everything. You will sweat, especially if you work, the environment is very cold, it's quite cold. I couldn't remember, I think it's about 25 degrees C or so. But then last time I was in equipment engineering team in lithography process. So we change pumps, we change robot arms, we do robot arm teaching, we change heavy stuff, we remove a controller, we change electronic boards. So you will be moving around a lot in the equipment or around the equipment. So walaupun your environment is quite cold, so you will actually sweat as well. So just imagine you sweat in the bunny suit in a cold environment. You will eventually get cold though, but when you do the work, when you are actually doing the work, changing pump, removing fan, or changing controllers, removing arm, teaching robots and everything, you will actually sweat. So you don't want to do chain reaction of contamination. You sweat and then you wear makeup, and then some parts of the makeup come off and contaminate your environment in your wafers. Okay, so that's why it's not allowed in the first place, because it will potentially lead to contamination on purpose. If not. All right, so that's it for today. Any other questions for clean room? Kita tak habis lagi ya. So we're just on page. So ini baru page berapa ni? So we're only on page. Hold on. Yeah, we're only on page 13. So we'll move on tomorrow to the rest of the content for clean room. Okay, any other questions for me? We'll resume tomorrow on clean room. Ada? All good. Okay then, if there's no question, then that's it for today. I'll see you again tomorrow, inshallah. Bye-bye. Assalamualaikum. Have a good day, you too. Take care.